say we were gonna add?
All of this.
All of them. So we'll review the sine, the cosine, and the tangent, and then we'll throw in the cosecant, the secant, and the cotangent. Okay? Everybody good with that? So everybody prepared to go down the road? Okay, and again, on every problem, it's amplitude, period, phase shift, increments, and graphing. Okay? So first, Delaney, what would be the amplitude?
The amplitude is 5.
Period would be what, Zach?
360 divided by k, which is 2.
So that would be
180.
180. Phase shift would be what, Dalton? Oh, yeah, Dalton, what would it be?
It would be negative 30 divided by 2, and that would be 15 negative.
Good. Increments? Mason?
360 divided by 4.
I disagree with 360. What's the period on this particular problem?
Oh, 180 divided by 4, I'm sorry.
So that would be 45?
Yes.
Okay, Delaney, number 2. You get to start us at a negative 15, and where will we end at?
195.
Try that again. One's positive and one's negative.
160.
So we're starting at a negative 15 and you're adding increments of 45. So Delaney, what would be next after the negative 15?
30.
Then what?
75.
120.
120.
Good.
And 160.
Okay, now, Becky, what's true of the sine curve? You did this last Friday. Sine is,
Starts at 0, middle of 0, the end 0.
okay, and then at the quarters, it's at its, what's our amplitude, 5?
So it's highest.
Be careful though.
Oh, it's negative, so it's low and then.
Yeah, starts low, then goes up. Okay, Tara, what would it be? Amplitude.
2.
Why, what would the period be?
360.
Divided by, what's the
1.
coefficient?
Or no, 1/2.
1/2.
So it's in 1.
Right. Phase shift. JC.
Oh.
Bill.
Jaylee.
You're Jaylee. Let's have Jaylee do it.
Okay, so it'd be C, which
What's my C? What's added there?
is 0.
Right. So it's just gonna be 0, right?
Yeah.
Okay, what's the increments gonna be? Taylor.
720 degrees divided by 4.
So that would be 180. Okay, JC, we're gonna start at 0. Where will we end? And then you're gonna go by increments of 180 starting at 0. I'll put this one over at the side since we've got so many more to go on here. So we're starting at 0, adding 180. So what's next?
20.
What's after that?
360. 540.
Good.
And 720.
And we have an amplitude of 2. Richard, what does a cosine curve look like?
It begins at the top and it reaches 0 at the quarters.
Right. And it ends at the top, and it goes down in the middle?
Yes.
Let's do this.
Yes, ma'am.
Will you sit up for a second?
Yes. Everybody about caught up? Okay, so then we're ready for, who are we ready for? We're back to Delaney. What's the amplitude? See if I catch you sleeping. I caught you sleeping.
Undefined.
There we go. Period. Zach,
Oh, 180 divided by K,
so that would be 180 divided by what?
1,
So that would be
180.
180. What do we do with that, Dalton Pyron 2?
You can change it to, degrees,
By, multiplying by,
180.
What's that?
Cancel, and then it should become 90.
okay, so what's our phase shift gonna be then?
190 divided by 2, that'd be 45.
Now, are you dividing it by 2?
Oh, divided by 1, sorry, so it'd be 90.
Right. Increments, what would they be, Mason?
They would be 180 divided by 2,
Which is?
90.
Okay, so here's where we're starting. Where will we end Delaney 2?
270.
Good. And so you're gonna start us at 90, and adding increments of 90, what would be next?
180.
And then what would be next?
270.
Good. Now, this is an undefined amplitude, right? So what's that tell you that you gotta have in your graph? Asymptote. So where's my asymptote on a tangent curve?
In the center.
It's in the middle. So I like different colors for my asymptote so it's easier to see. So we start at and go to the asymptote, right?
Mm-hmm.
And then we come from the asymptote back to 0. Okay. Does the 5 affect it any at all?
No.
Well, actually it does. It just makes it get steeper faster, but it doesn't affect your graphing. It's just gonna get closer to the asymptote quicker, that's all it's gonna do. It's not gonna start at 5, it's always gonna start at, what's that point? 0. 0. So it's gonna start there at 0. Okay, ready for the new ones. Since we just did tangent, let's do cotangent. We're ready for Becky, I guess. What would be our amplitude? Undefined. What's going to be true of all the ones we have remaining? They're all undefined for amplitudes. That means you're going to have what? Asymptotes. Okay, what would be the period? Tara?
180 divided by 2.
Which is?
90.
Phase shift? What?
30 divided by 2, so 15.
Increments? Taylor? Oh, I missed
So is
Taylor.
that a 30? Minus
Yes.
30? Okay.
Yeah, that's a 30. It may look like a 6. Jaylee, what would we do for increments?
90 divided by 2. 45.
So we're starting at 15. Taylor, where will we end?
105.
So our graph's gonna start at 15 degrees. You're adding increments of 45, so what would be next, Taylor?
30. Or, sorry. I was trying to.
Not 30, you're right.
Mm, 60.
60 is correct. What's next?
105.
105. Okay. Where are the asymptotes on a cotangent curve? And that's where we stop, right? 105 is what we're stopping for.
Yeah,
Beginning
so
and the
it'd be
end.
at the beginning and the end.
The beginning and the end. It's the inverse of tangent. I mean, the inverse trig. So notice it's in the middle on this one, and it's in the beginning and the end. See, it's the opposite, basically. Okay, and now, what happens with the graph? Doesn't it always cross in the middle at 0? It starts high and goes low. I think we can squeeze another one in here. Okay, we're doing the secant. So JC, what is the amplitude?
2.
Be careful.
Oh,
Undefined. Richard, what about the period?
It's 360 degrees over the K, which is 1, so you get 360 degrees.
Phase shift, we're back to Delaney.
and that is 300. Okay, that is negative 45
Mm-hmm.
over 1, so just 45.
Increments. Zach,
360 divided by 4.
right? Would be 90. Is everybody good to that point? Do I need to slow it down? Yes. Ready for the graph? Okay, so I'm ready for, we're gonna start it at 85. Dalton, where are we gonna end it?
315.
315. And you get to do the starting at negative 45, adding increments of 90, so what would be next?
45.
Next,
135.
next,
225.
next.
315.
Is everybody in agreement with our values there? Do we know we're right or wrong? We are right, because weren't we supposed to end at 315? So you got that to go with. Now, secant curve, where are the asymptotes?
They are the quarters.
At the quarters. I don't know if I remember telling you this, but I always think of the secant curve as the window curtain.
Oh, yeah.
Remember, it looks like the window curtain is the side, and then you got a parabola in the middle. But this 2, now notice over here I said this 5 really didn't affect the graph, it just makes it get steeper. This affects the graph. It tells you where you're starting your window curtain from. So we're gonna be starting from 2 and going to the asymptote. We're gonna come back from the asymptote back to 2. And then our parabola is gonna be down at a negative 2, letting the water out. So again, this 2 does affect it. It starts where the graph starts from. So it's 2 to the asymptote, it's back from the asymptote back to 2, and then it's the parabola inverted. Mason, do you have a question?
On your, where it starts at 2,
See, here's where the negative 45 is, which is your
Right.
starting point. You
yeah.
go up to 2 because that's that number that's in front. So that's where you're starting from, and then you're gonna go to that asymptote. Okay, everybody good on secant? Let's see, we're ready for us to go to the, what's left? Cosecant. I wanna make us think on this one. Let's try to ret. Becky? No?
Mason.
Mason, okay, Mason.
Except I can't find where it's, oh. Minus 6
Yeah, negative 3 cosecant of quantity 2x plus 60. So you're gonna answer the question, what's the amplitude?
It is 3.
Be
Oh wait,
careful.
no, it's cosine, undefined.
Undefined. That means we're gonna have asymptotes. What's the period gonna be, Delaney 2?
180.
180, 360 divided by 2, which if you can do that mentally, you don't have to write it down, I'm just writing it down for the benefit of everybody. Becky, what's the phase shift? Negative C over K, so that would be,
Negative 60 over 2.
so negative 30 then?
Yes.
Okay, Tara, what would be our increments?
180 divided by 4, which is 45.
So Wyatt, we're gonna start at a negative 30, where will we end?
1.
starting at a negative 30, adding increments of 45, what would be next? 15, then what's next?
60,
Next,
105,
next,
150.
right. And let's see, ready for everybody to tell me, where are the asymptotes?
At the beginning, middle, and
Beginning, middle, and the end. Everybody got that for cosecant? And what's it normally do? Normally it holds the water and lets the water out, two parabolas, everybody agree?
yeah,
What's that gonna do to it?
it's gonna go up.
It's gonna go down first, so I have 3 as the starting point, but we're gonna start down at a negative 3 and go to the asymptotes, and then we're gonna be up 3, getting close to the asymptotes without crossing or touching. So this number does affect it again, and the negative inverted the way it went. Instead of starting up first, it went down first. Now, if you've got those written down, you shouldn't need any more examples unless if you wanna write down another one. I thought we'd do another one of, which one do you dislike the most?
I had a question.
Yes.
On, the one we just did,
Mhm.
where is the parabola?
It's gonna start at a negative 3,
Okay,
because that's what number's there, so we start down at the quarters at the negative 3 and drew water out, and then at the other quarter it's gonna be a positive 3. Normally it starts up though, Mason. Because of that negative, it had to start down.
okay.
Well, let's throw in another one just to have you guys help me. Let's go secant of 3x. I think we're ready for one more table. What would be the amplitude?
1.
Secant.
Oh, undefined. I
Undefined.
was thinking sine.
Period. What would it be, JC?
360 divided by 3.
Phase shift, what would it be, Richard?
Negative 0 over k, and k to 0.
So it's 0. There's nothing added or subtracted. Increments, which you're gonna have a few on the worksheet that's gonna be 0. What are the increments gonna be, Delaney?
Increments are going to be 120 divided by 4. So that is 30.
30? So we start here. Where will we end at, Zach? 120. So starting at 0, going by increments of 30, aren't we gonna have 30, 60, 90, 120, and we know we're good? Where are the asymptotes on a secant curve? Quarters. And what's the secant curve look like?
It's right.
It's the window curtain, so we're gonna, what's the coefficient there? 1, so we're gonna start 1, come back to 1, and down here, we're gonna be down 1, let the water out. Okay, do you guys have questions? You want more examples? Does everybody feel confident? Okay, worksheet, what one are we ready for? Worksheet number 2, yep, find it on my desk.
What's the best that would be called?
I'm gonna go over that, so.
Okay, first one.
I've got that covered, so just a second, as soon as I get these passed out, I'm gonna let the others go ahead and get started that are gonna be here tomorrow. They won't have to even listen to this. And see, Becky, I need to give you the makeup from yesterday, right? Which is the same thing, except you don't have sequence code.
Okay.
And you can turn the camera off now. So next week we'll see this without the problem. So if you're gonna be gone tomorrow,